Today we are going to discuss solutions of KVPY 2018. So this is question number 13. So in question number 13 they said S is a set where this function is defined. So S is going to be minus infinite to minus 1 union 1 to infinite, because basically logarithm of x square minus 1, this has to be positive, so you have x square greater than 1. So x is varying from minus infinite to minus 1 union 1 to infinite. So basically the set S is this. So now the required condition is we need to find the number of functions which will satisfy this condition. F dash of x is equal to ln of x square minus 1 for all x belongs to S. हर एक x के लिए ये true होना चाहिए. So let us try to integrate this function, then we'll get f of x, and they have given a condition as well, that is f of 2 must be 0. F of 2 must be 0. So let us try to integrate. If we integrate this, we have f of x is equals to integral ln of x square minus 1 dx. So if we do integration by parts, we have x into ln of x square minus 1, considering 1 as my second function, minus you will have a integral of 1 upon x square minus 1 into 2x into x, that is 2x square. So I'll write 2x square dx. So after integrating this, what do we have? We have x ln of x square minus 1 minus 2 times of, so we will split it here, x square minus 1 plus 1. So you will have 1, and then you will have 1 upon x square minus 1. Integration of 1 is x, plus 1 upon x square minus 1 is half ln mod x minus 1 upon x plus 1 plus c. Okay. So this is the integral of f of x. Now as we can see, the function has actually two branches. One is before minus 1 and another is after plus 1. So the function, this function looks something like this. Okay. So when we integrate, we got f of x, and this is also defined from 1 to infinite and minus 1 to minus infinite. So qualitatively, if we see graph of f of x, it will be something like this. So in this interval it will be increasing, then it will be decreasing, maybe something like this, till here it will be increasing because it is positive, and then negative because the derivative of this is this. Similarly here also, in this interval the function will be decreasing and here it will be increasing, so it will be like this. So this function has actually two branches. One branch is on the left side of minus 1 and other branch is on the right side of plus 1. So now we have been given a condition that f of 2 is 0. That means this point, this branch has to satisfy condition that f of 2 must be 0. Let us say 2. So this point should be 2 comma 0. F of 2 must be 0. So if we put x equal to 2 and f of x value 0, we'll get c. We'll get c is equals to 4 minus 3 ln 3. 4 minus 3 ln 3 using this condition. Put x equals to 2. Put x equal to 2 and f of x as 0. So from there we'll get c. c equals to 4 minus 3 ln 3. So now there is condition only on this. Now this branch is free. We can just add some constant to this branch. Still the derivative is going to be this for all the points. So I will define a new function, or I will define f of x something like this. f of x is equal to, let's say, this whole thing plus you have 4 minus 3 ln 3 if x belongs to 1 to infinite, and I'll have this plus some constant if x belongs to minus infinite to minus 1. Okay. So if we define f of x like this, then we have, see, this, the derivative of this is always going to be this. So this condition is satisfied. The value of f of 2 is going to be 4 minus 0 with this constant. So these, both the conditions are satisfied. Now this k, we can vary k, we can choose any real number. So this essentially gives us infinitely many functions. By varying k, we'll get infinitely many functions f of x. That's it. Thank you.